Welcome back to Homework Genius. In this video, I'm going to show you how to find even and odd functions. The function y equals f of x is even if f of negative x equals f of x. And the function y equals f of x is odd if f of negative x equals negative f of x. Let's try an example so I can show you how that works. We are told to determine if the function is even, odd, or neither, and then to find the zeros. We are given the function f of x equals x cubed minus x. In order to find whether a function is even or odd, we would find the function at negative x and assess the outcome, if the function doesn't change or if the function becomes the negative version of itself. So let's find this function at f of negative x, meaning that wherever there's an x, we're going to replace it with a negative x. So we can write it as negative x cubed minus negative x. And now let's simplify. F of negative x equals, if you have a negative x cubed, you're still going to have a negative x cubed. And minus negative x turns into plus x. So since we're left with negative x cubed plus x, and if you look at our original function given, x cubed minus x, the resulting function is just the negative version of what we were given. So that means that f of negative x equals negative f of x, meaning that f of x is odd. So what does it mean when a function is odd? A function is odd when it is symmetrical about the origin. I'll show you later what that looks like so you can visualize it. Let's try one more example. We are given the function g of x equals 3 over x squared plus 2. So let's find it at g of negative x. Again, we would just replace any x's with a negative x. So in this case, it's 3 over negative x squared plus 2. And if we simplify that, we get that g of negative x equals 3 over negative x squared would be positive x, so x squared plus 2. And if we look at our original function given, that g of x equals 3 over x squared plus 2, we got the exact same thing. So g of negative x equals just g of x. Therefore, g of x is even. And a function is even when it is symmetrical about the y-axis. I'll also show you what that looks like. Before I do that, let's go ahead and find the zeros of each function. Let's go back to this f of x. To find the zeros of a function, you would just take that function and set it equal to 0. So in this case, our function f of x is x cubed minus x, and we'll set that equal to 0. And now we can solve to find all our zeros. The first thing we want to do here is factor out one of the x's. So we have x times x squared minus 1 equals 0. And you can set both those terms separately equal to 0. So x equals 0 and x squared minus 1 equals 0. And for this x squared minus 1, let's go ahead and simplify that. We can add that 1 to the other side. So we have x squared equals 1, and let's square root that x. So we're left with x equals positive or negative 1. So our zeros here are x equals 0, 1, and negative 1. Now let's find the zeros of g of x. We would set that function equal to 0, so 3 over x squared plus 2 equals 0. And in this case, when simplifying, you would take that x squared plus 2 and multiply it to the other side times that 0. But if you do that, you get 3 equals 0, which is undefined. Therefore, g of x does not have any zeros. Now let's graph these functions. Let's start with our function f of x equals x cubed minus x. We can just do this by plugging in some numbers and plotting some points so we can visualize it. Let's start with x equals 0, so wherever there's an x, we'll just plug in a 0. And if we do that, we just get y equals 0. So 0, 0. At x equals 1, 1 cubed minus 1, y also equals 0. So 1, 0. And if we see what happens in between those 2 points at x equals 1/2, y equals negative 1/3. And at x equals 2, y equals 6. And I'm going to go ahead and do that also on the other side of y, so just the negative version of everything. So at x equals negative 1, at x equals negative 1/2, at x equals negative 2, and we can go ahead and draw this graph. So it looks something like that. So if you notice, we had found earlier that this function is odd, meaning that it's symmetrical about the origin. So the origin here is at 0, 0 in the center, and something that's symmetrical about the origin means that it's symmetrical about both the x and the y-axes. If you flip this about the x and then about the y-axis, you're going to get this on the left here. So looking just to the right of the origin here, if you just flip this about the x-axis, it looks something like this. Now if you take this and you flip it about the y-axis, you get this over here. So that's what it means to be symmetrical about the origin. Now let's graph the function g of x. G of x equals 3 over x squared plus 2. So again, let's just plot some points like we did last time. At x equals 0, at x equals 1, y equals 1, at x equals 3, y equals 3 over 11, and then at x equals negative 1, y equals 1, and at x equals negative 3, y equals 3 over 11. And if you remember, we found that the function is even, meaning that it's symmetrical about the y-axis. So we see here that it looks the same on the right of the y as it does on the left of the y. Here's the full problem so you can screenshot it for your notes. And here are the graphs. I hope this video helped. Let me know if you guys have any questions in the comments below. Thanks for watching!